Your body has a repair system that most people never learn to use. It doesn't work like a light switch you flip once and forget. It works more like a habit you build, and the science behind it has gotten a lot more interesting in the last few years. Here's the part that surprises people. Your bone marrow keeps producing stem cells throughout your entire life, even into your 70s and 80s. What changes with age isn't that the supply runs out. What changes is how efficiently those cells get activated and put to work. Researchers studying this have found that the same signals that wake up dormant stem cell activity also tend to push your metabolism toward burning stored fat instead of holding on to it. That overlap isn't a coincidence. Both processes are tied to how your body senses stress, scarcity, and recovery. Doctors who study aging and metabolism have started paying close attention to a small set of everyday habits that seem to influence both systems at once. None of them involve a prescription, none of them cost much, and several of them can be started tonight. It's worth being clear about why this matters, beyond just the science being interesting. Regenerative medicine, as an industry, is enormous, and stem cell injections and prescription fat loss treatments are two of its biggest revenue categories, often billed separately, even though the underlying biology overlaps more than most people realize. That doesn't mean the injections and prescriptions don't have their place, especially for people with specific medical needs. But it does mean there's very little financial incentive for anyone to tell you about the free version of what your body can already do on its own. To be upfront, most of the biggest effect sizes in this research come from cell cultures and animal studies, not large human trials. Where solid human data exists, I'll tell you. Where it doesn't yet, I'll say that too. This isn't the miracle list, and nothing here works instantly or replaces medical care when you actually need it. It's a rundown of 6 habits with a real, if sometimes modest, evidence base behind them, ranked from solid to the one researchers seem most excited about right now. Pay particular attention to the third one, since it costs nothing and has some of the more consistent human research behind it of anything on this list. Let's start with something sitting in most kitchen cabinets already. Number 6, turmeric, and specifically the way you eat it. Turmeric's reputation as an anti-inflammatory spice isn't new. What's newer is research into curcumin, the active compound in turmeric, and its direct effects on stem cells and fat cell formation. Laboratory studies on human mesenchymal stem cells, the cells responsible for regenerating bone, cartilage, and connective tissue, have found that curcumin can promote their proliferation while simultaneously suppressing adipogenesis, which is the technical term for the process of forming new fat cells. In other words, in these cell studies, curcumin appeared to push cellular resources toward regeneration and away from fat storage at the same time. Here's the catch almost nobody hears about. Curcumin on its own is absorbed by the body remarkably poorly. Most of what you eat passes through without ever reaching your bloodstream in meaningful amounts. This is where a genuinely well-established finding comes in. A study published in Planta Medica back in 1998 found that piperine, the compound responsible for black pepper's bite, increased curcumin's bioavailability by roughly 2,000% when the two were combined. That number holds up and gets cited constantly in nutrition research because it's such a dramatic effect from something so simple. So the practical takeaway is this: turmeric without black pepper is mostly wasted turmeric. If you want your body to actually use it, combine about a teaspoon of turmeric powder with a small pinch of freshly ground black pepper and a source of fat, since curcumin is fat soluble and needs fat present to be absorbed properly. Olive oil, coconut oil, or just stirring it into a dish that already contains fat all work. You can mix this into warm water, a smoothie, scrambled eggs, or a curry. Human trials on curcumin supplementation for body composition do exist, and some show modest reductions in body fat and inflammatory markers like C-reactive protein over 8 to 12 weeks, though results vary between studies and doses used. Timing also seems to matter somewhat. Taking curcumin alongside a meal that already contains fat tends to improve absorption compared to taking it on an empty stomach, which is one more reason to fold it into food rather than swallow it as a standalone powder. Consistency matters too. The cell-level changes researchers observe happen quickly in a lab dish, but the body composition changes seen in human trials generally take several weeks of daily use before they show up on a scale or in blood work. This is a slow-building habit, not a same-day fix, and it's worth setting expectations around that from the start. The honest summary is that turmeric with black pepper is a low-risk, reasonably well-supported habit, not a fat loss shortcut on its own. Now let's move to a compound with a much longer history and a stronger emerging research base. Number 5, black seed oil. Nigella sativa, commonly known as black seed, has been used in traditional medicine for centuries, and modern research has been catching up to why. The key active compound is thymoquinone, and a growing body of animal and cell research suggests it has notable effects on stem cell activity, particularly in hematopoietic stem cells, the cells responsible for producing blood and immune cells. When these cell populations are more active, the general expectation is better immune function and tissue repair capacity, though most of this specific stem cell data comes from animal models rather than humans. The fat metabolism research is where black seed oil has more direct human evidence. Several randomized controlled trials, including work published in journals focused on diabetes and metabolic disorders, have given overweight participants daily doses of black seed oil for 8 to 12 weeks and found modest but consistent reductions in body weight, waist circumference, fasting blood sugar, and triglycerides compared to placebo groups. The effect sizes are real but modest, generally in the range of a few kilograms of weight change over 2 to 3 months, not dramatic transformations. Part of the proposed mechanism involves AMPK, short for AMP activated protein kinase. Think of AMPK as one of your body's central metabolic sensors. When it's activated, cells tend to shift toward burning fuel rather than storing it. This is the same pathway influenced by exercise and fasting, and some research suggests thymoquinone may activate it through a different route, which is part of why it interests researchers looking at metabolic health from multiple angles at once. That doesn't mean it works as well as exercise or that it can substitute for it, but it does help explain why researchers see it as complementary to other habits rather than competing with them, since it may be acting on a shared pathway from a different direction. If you want to try it, most of the trial doses used range from 1 to 3 grams daily, roughly half a teaspoon to a full teaspoon, often taken on an empty stomach in the morning, since some pharmacokinetic research suggests absorption may be somewhat better in a fasted state. The taste is strong and bitter, so many people mix it with a small amount of raw honey, and some smaller studies have looked at combining the two for an added anti-inflammatory effect, though that combination-specific research is still limited. Buy cold-pressed organic black seed oil in a dark glass bottle, since phymoquinone degrades with heat and light exposure, and independent testing of different brands has found real variation in actual phymoquinone content compared to what's listed on the label. If you're trying it for the first time, starting with a smaller amount for the first week and increasing gradually gives your digestive system time to adjust, since some people notice mild stomach upset at the full dose right away. Next up is something you eat raw, and the reason it has to be raw is actually the most interesting part of the story. Number 4, raw broccoli sprouts. This isn't about broccoli as a side dish. Broccoli sprouts, the tiny plants harvested just 3 to 5 days after germination, contain dramatically higher concentrations of a compound called sulforaphane than mature broccoli does. Sulforaphane has become one of the most studied plant compounds in aging and cellular defense research, largely because of work coming out of Johns Hopkins over the past 2 decades. Sulforaphane's main mechanism is activating something called the NRF2 pathway, a master regulatory switch present in nearly every cell in your body. When NRF2 is activated, it turns on the production of hundreds of protective genes involved in antioxidant defense, detoxification, and inflammation control. Some research in animal models has linked this activation to improved stem cell survival and function, including in neural tissue, though translating those specific findings directly to humans still requires caution. On the metabolic side, some clinical research has found that sulforaphane supplementation over several weeks is associated with improvements in insulin sensitivity and modest reductions in visceral fat, the fat stored around your abdominal organs that's more metabolically active and more linked to health risk than fat stored elsewhere. Better insulin sensitivity generally means your body is less likely to convert excess blood sugar into stored fat. The critical detail is that sulforaphane doesn't exist in the raw plant. It's formed when an enzyme called myrosinase interacts with a precursor compound, and cooking destroys that enzyme. Studies on vegetable preparation have found that steaming broccoli for even a couple of minutes significantly reduces sulforaphane formation, and boiling reduces it even further. That's why the sprouts need to be eaten raw or only very lightly prepared. To grow your own, soak a couple of tablespoons of organic broccoli sprouting seeds overnight in a jar. Then drain and rinse them twice a day for 3 to 5 days until you have a jar of fresh sprouts. Chewing them thoroughly actually helps, since it physically mixes the enzyme with its precursor compound right in your mouth, which is a small detail, but a real one. A pinch of mustard seed powder added to your sprouts can boost sulforaphane formation further, since mustard seeds are also rich in myrosinase and can compensate somewhat if your homemade sprouts have lost some enzyme activity during storage. Add them to salads, smoothies, sandwiches, or eat them on their own, straight out of the jar, and store them sealed in the fridge, where they generally stay reasonably potent for about 5 days before quality starts to decline. If growing your own isn't practical, many grocery stores now carry pre-grown broccoli sprouts in the produce section, though checking how fresh they are matters, since sulforaphane potential does decline over time even under refrigeration. Now for a method that costs absolutely nothing and has one of the more robust human evidence bases on this list. Number 3, cold water exposure. This one is uncomfortable, and that discomfort is actually part of the mechanism. When your body is exposed to cold, your nervous system releases a surge of norepinephrine, a hormone and neurotransmitter involved in alertness, metabolism, and fat regulation. Human studies going back over a decade, including research published in the Journal of Clinical Investigation, have used PET imaging to show that repeated cold exposure increases the activity of brown adipose tissue, commonly called brown fat. This distinction matters. White fat is your body's long-term energy storage, and it's the type most associated with stubborn weight gain. Brown fat works differently. It burns calories to generate heat rather than storing energy. Studies measuring brown fat activation after sustained cold exposure protocols have found meaningful increases in resting energy expenditure, though the exact numbers vary a lot between individuals and studies. And not everyone responds the same way, since the amount of brown fat a person has varies naturally. On the stem cell side, the research is earlier stage. Some animal and cell studies suggest that norepinephrine released during cold exposure can stimulate mesenchymal stem cell activity and mobilization from bone marrow, theoretically supporting tissue repair processes throughout the body. Human confirmation of this specific effect is still developing, so treat it as a promising area of research rather than settled science. The practical approach doesn't require an ice bath. Most researchers and clinicians who study this recommend starting small. At the end of a normal warm shower, switch the water to the coldest setting for 30 seconds. Over the following 2 weeks, gradually work up to 2 or 3 minutes as your tolerance builds. Reviews of the cold exposure literature suggest that benefits tend to plateau somewhere around 10 to 15 minutes of total weekly exposure spread across a few sessions, so you genuinely don't need long sessions to get most of the benefit, and more isn't necessarily better past a certain point. If you want to go further, full immersion in a cold tub covers more surface area and tends to produce a stronger response than a shower alone. And exposing the face specifically triggers a physiological reflex that appears to amplify the norepinephrine release. Breathe slowly and steadily throughout to avoid hyperventilating, which is the most common reason people quit early. If you have any cardiovascular condition, it's worth checking with a doctor before starting, since sudden cold exposure does raise heart rate and blood pressure briefly. And that's a real consideration for some people, even though it's well tolerated by most healthy adults. Now the next method involves eating less, on a schedule, rather than eating something specific. Number 2, time-restricted eating. You've probably heard of intermittent fasting in some form, but the mechanistic research behind it goes deeper than simple calorie reduction. A widely cited 2018 study from MIT, published in Cell Stem Cell, found that a 24-hour fast roughly doubled the regenerative capacity of intestinal stem cells in mice, and notably, the improvement was more pronounced in older mice than younger ones. That's an animal study, not a human one, but it's one of the more compelling pieces of evidence connecting fasting directly to stem cell function rather than just weight loss. The proposed mechanism is that fasting forces cells to shift from burning glucose to burning fatty acids, which activates a signaling pathway associated with improved stem cell regeneration and with autophagy, the process by which cells clear out and recycle damaged internal components. In humans, the research on time-restricted eating for fat loss is more robust than the stem cell research, though the effect sizes are modest rather than dramatic. Systematic reviews of clinical trials have generally found that restricting the daily eating window to 8 hours or fewer leads to average weight loss in the low single-digit percentage range over 8 to 12 weeks, with some evidence that a meaningful portion of that loss comes from visceral fat specifically. Some research also suggests the specific fasting window matters, with benefits becoming more consistent around 16 hours of fasting rather than shorter windows, though individual responses vary. A practical way to try this: stop eating around 8 p.m. and don't eat again until noon the next day, giving you a 16-hour fasting window and an 8-hour eating window. During the fast, water, black coffee, and plain tea are generally fine, but anything with calories, sugar, or cream will interrupt the metabolic shift the fast is meant to produce, which is the most common mistake people make without realizing it, often without noticing that a splash of milk in their coffee has quietly ended the fast. Some research also suggests that eating your larger meals earlier in the day, when insulin sensitivity tends to be naturally higher, may modestly improve results compared to eating the same calories concentrated later at night. It's worth being honest that this approach isn't right for everyone. People with a history of disordered eating, anyone pregnant or breastfeeding, and people managing diabetes with medication should talk to a doctor before changing their eating schedule, since the effects on blood sugar and medication timing can be significant. And now, the method that researchers studying gut health and stem cell biology have gotten the most genuinely excited about recently. Number 1. Cooled resistant starch. Resistant starch is a type of carbohydrate that resists digestion in your small intestine. Instead of being broken down and absorbed as sugar, it travels intact into your large intestine, where specific populations of beneficial gut bacteria ferment it. That fermentation produces a short-chain fatty acid called butyrate, and butyrate has become one of the more closely studied compounds in gut and metabolic health research over the past several years. Research out of Stanford and other institutions studying intestinal biology has found that butyrate can meaningfully increase the regenerative activity of intestinal stem cells. Some research has also found that butyrate can cross into the bloodstream and influence stem cell activity elsewhere in the body, including some early evidence of effects on neural tissue, though again, much of the most striking data here comes from animal and cell studies rather than large human trials. The human data on resistant starch and fat metabolism is genuinely encouraging. Clinical trials giving participants around 30 grams of resistant starch daily for several weeks have found improvements in fasting insulin, post-meal blood sugar response, and in some studies, modest increases in fat oxidation, meaning the body's ability to actually use stored fat for fuel. Better insulin sensitivity generally makes stored fat more accessible for the body to burn rather than locking it away. Here's the part that makes this method easy to act on. You don't need a supplement. Cook regular potatoes, rice, or pasta, then let them cool completely in the refrigerator for at least 12 hours. As starch cools, its molecular structure changes, forming a more crystalline arrangement that resists digestion, which is exactly what creates resistant starch. Food science research has found that a cooled potato can contain several times more resistant starch than the same potato eaten hot, and that reheating the cooled potato preserves most of that resistant starch content, so you can still eat it warm later in the week. Cook a batch of potatoes, rice, or pasta ahead of time on the weekend, refrigerate it, and eat it throughout the week as a cold salad, a reheated side dish, or blend it into a meal. Green bananas are another solid source of resistant starch and can be blended into a smoothie without much change in taste, since the greener and less ripe the banana, the more resistant starch it contains. Legumes like lentils and chickpeas are also naturally rich in resistant starch, even without any cooling step, so they're worth including alongside the cooled starches rather than instead of them. Most of the research on meaningful metabolic effects uses somewhere around 15 to 30 grams of resistant starch daily, and pairing this with a time-restricted eating window by eating it during your first meal of the day may compound the benefits, since that's when insulin sensitivity and the digestive system are best positioned to make use of it. One practical note worth mentioning: increasing resistant starch intake quickly can cause temporary bloating or gas as your gut bacteria adjust. So easing into it over a week or two is more comfortable than jumping straight to the full amount. So there you have it, 6 habits with real research behind them, ranging from turmeric and black seed oil to raw broccoli sprouts, cold exposure, time-restricted eating, and cooled resistant starch. None of them are a substitute for medical care if you're dealing with a real health condition, and none of them will transform your body overnight. But each one has a genuine, evidence-backed reason to be worth trying, using things that are already accessible and inexpensive, and several of them appear to work through overlapping biological pathways, which is part of why combining a few of them rather than picking just one seems to be where the more promising results in this research tend to show up. You don't need to start all 6 at once. Pick the one that fits most naturally into your week, whether that's the black pepper and turmeric habit at dinner, the cold shower in the morning, or shifting your eating window by an hour or two. And give it a few weeks before judging whether it's doing anything. Real physiological change, the kind involving stem cells and metabolism, tends to happen on the timescale of weeks and months, not overnight, no matter what any video promises you. If any of this was useful, hit subscribe so you don't miss the next one. Thanks for watching.